Welcome to Engineering Essentials. Today we'll be comparing transformer power supply with the SMPS power supply. For that, we need to look at a typical amplifier circuit. We can clearly see there are three power input terminals. That means you definitely need a 3-wire power supply. And also there are positive rail filtering capacitors and as well as negative rail filtering capacitors. Clearly, this board is designed for a transformer power supply. You can see the 3 terminals as well as a bridge rectifier. I will be reviewing this amplifier board in an upcoming video, so make sure you subscribe to this channel and turn on the bell notification icon. Let's move on and talk about the 3-wire power supply. We can make this in 2 ways. Either you can use a transformer or you can use a SMPS. Let's talk about transformer power supplies. In a transformer power supply, there are many secondary windings. Like you can see here, this transformer have 3 secondary windings. One is blue, one is yellow, and other one is black. You will notice that the black wire is thicker. It is having the highest current rating of 5 amps. Okay, then let's move on to the primary side. The red wires are corresponding to the primary side. This is a high voltage side and which will be connected to 240 volt. The secondary voltage is determined by the number of turns in the corresponding winding. The important thing is that each of these windings will be electrically isolated. There will be no direct connection between primary side and secondary side, and it is one of the primary requirements of a consumer appliance. It should be isolated from the mains power supply so that the risk of electric shock will be minimized. Let's keep the transformer aside and move on to SMPS power supply. A typical SMPS like this one will be having only one power rail. That means 2-wire power supply. The green terminal you see here will be connected to 240 volt, which is then connected to a fuse and then connected to a inrush limiting resistor and then connected to common mode choke in order to filter out the switching noises, then EMI suppression capacitors, and finally it comes to the bridge rectifier. After rectification, the 325 volt DC will be stored in the capacitor. The capacitor is rated for 400 volt and 100 microfarad. Now this 325 volt DC is supplied to the high frequency transformer next to it. In order to convert the DC into high frequency pulses, we need a power switch. Transformers should not be used with DC. This flyback transformer is responsible for the isolation as well as the voltage reduction. The previously shown power switch is controlled by this small IC. It is actually responsible for the regulation also. Regulation is achieved by pulse width modulation or pulse position modulation or pulse frequency modulation. Similar to a power transformer, flyback transformers also have primary as well as secondary. You can see on the other side of the board there is a large gap between the traces. This is to ensure that under no circumstance the primary voltage should appear in the secondary side. In addition to the gap between the primary as well as secondary side, there will be small cutouts in the board. Similar to a normal transformer power supply, we have a rectifier at the secondary side. This is the rectifier mounted onto a heatsink and then connected to the secondary filtering capacitors, then the terminals. There are 4 terminals given, 2 of them are positive and 2 of them are negative. 2 of these terminals are taken from the same traces. Polarity of these terminals are marked on the board. This is a 24 volt 5 ampere power supply, which is ideal power supply for TPA 3116D2 boards, which are class D internally bridged boards. Any single supply amplifiers can be operated with this power supply. Yes, there are methods to convert this single power supply into dual power supply. That will work for low powered amplifiers, but for high powered amplifier you definitely need a dual power supply. The problem is solved if you have two of these. Definitely you can combine them and make a 3-wire power supply. Now we have 4 terminals instead of 3. Yes, you guessed it, we need to combine 2 of these 4 terminals. Positive terminal of one SMPS combined with the negative terminal of other SMPS will give you the ground. The remaining positive terminal of one SMPS and the remaining negative terminal of the other SMPS will give you the other 2 power rails. Care must be taken to not connect positive and negative terminal of the same SMPS together. Even if you have 2 batteries also, you can connect in this way. Connect positive terminal of one battery with the negative of other. This will give you the ground terminal, and other one positive terminal will give you the positive rail, and other one negative terminal will give you the negative rail. If you are using 2 SMPS, one of them can produce output first and cause single rail operation of the amplifier, which is very dangerous and the amplifier may be damaged. The solution is to use a dual supply SMPS, which can produce both positive as well as negative rails simultaneously. The dual power supply is created by the resonance transformer itself, which is then rectified and filtered and available at the output terminal itself. This is a dual output SMPS and we are having both power connector as well as auxiliary connector. On the power connector we have positive, ground and negative terminals for the amplifier and an auxiliary supply of 15 volt dual. This one is actually an LLC power converter, which is different from normal PWM converters. Unlike a PWM converter which is having a fixed current limit, this power supply is capable of delivering high peak currents to the load, which is an advantage when considering an amplifier. LLC technology is based on resonance power conversion that reduces the losses in the circuit. If you are considering building an amplifier with an SMPS, go for an LLC converter instead of a PWM. Since this one is a Class D amplifier, I recommend using an LLC converter for this one. Let's move on to the side-by-side comparison. Let's start with the important parameter, voltage stability. Due to the passive voltage regulation, transformers will have the poor voltage stability. Voltage stability also dependent on the output impedance of the transformer. Toroidal transformers will have lower output impedance as well as better voltage stability. In the case of an SMPS, we have an active voltage regulating loop, so it will maintain the voltage. Good quality means higher cost, which is applicable for SMPS as well as transformer. So cost will be moderate on both the side. Next we can move on to efficiency. Due to light load operation, transformer efficiency will be low compared to SMPS. Next one, dynamic power. Dynamic power is the instant power delivered to the load when the amplifier is required to deliver a peak current. Peak current capability of a transformer is high because it possesses overload capacity, whereas an SMPS is limited in overload capacity, but the peak current requirement can be satisfied by the bank of capacitors. Next one, continuous power. Due to the output impedance and high regulation by the transformer, the power delivered continuously, that is RMS power, will be low, whereas an SMPS can deliver rated current at a rated voltage without any voltage loss. Transformer can deliver higher currents than its rating but at a loss of voltage. But for an SMPS, the output current is limited internally. Multiple outputs are possible in both the transformer as well as SMPS. You can see there are multiple outputs from the same transformer. Any kind of power supply noises can come through a transformer, but in case of SMPS, since the output voltage is regulated, these noises will get rejected. Transformers can only alter the voltage, not frequency, not wave shape. If there is a voltage spike in the primary, that voltage will be reflected on the secondary also. Power supply switching noises can easily get into your amplifier, but in SMPS that is not the case. Next, consider the weight. We know transformers are heavy due to the presence of iron magnetic core. Transformer in an SMPS will be very small and lightweight. Wear rating of the transformer should be double that of the amplifier. Technically, that rule is also applicable with the SMPS also. When talking about isolation, we have seen already both SMPS and transformers will provide isolation. Next comes the standby power consumption. Due to the large core of the transformer, there will be substantial no-load losses. With the SMPS, we can reduce the idle loss to almost zero. For higher power applications, it is always better to use SMPS instead of a transformer. Power amplifiers above 1000 watts will use SMPS. The audio noise which is inserted to the power supply side is moderate in the case of a transformer because it draws peak currents. With SMPS, there are input common mode filtering chokes as well as capacitors, and with the help of power factor correction, we can achieve a power factor up to 0.95, whereas in a transformer, you can get up to only 0.8. For the conclusion, when we have low impedance loads 4 ohm or below, when we have very large filter capacitors available, when the amplifier can accept wide variety of operating voltages, and there is no current limit involved in the circuit, go for toroidal transformer. If the speaker impedance is high, 4 ohm or 8 ohm, if you need your amplifier to be compact and light, if the amplifier does not have a wide variety of operating voltages and also incorporates a current limit, low power supply rejection ratio, PSRR, need a high efficiency amplifier, then go for a SMPS power supply with LLC power conversion will give you the best result. Based on your requirement, you can choose either transformer or SMPS. On the upcoming video, we will do a power test with the transformer as well as SMPS. Thank you for watching. See you